Welcome back, everybody. I hope you enjoyed lunch. And I am going to welcome Vincent, who is a software engineer working for Red Hat. He's going to tell us something about container and standards. Is that right? All right. Have fun.
All right. Can y'all hear me okay? Yeah, sure. Going to be talking a bit today about common container standards. You've heard this already a number of times this morning. Brandon mentioned it this morning on the keynote. John Bull mentioned it just a few minutes ago in his Rocket Netties talk. Past, present, and future. So a little bit about who I am. I've been in and around open source community for a long time, sometimes an unfortunate amount of time. I've been with Red Hat now for over 4 years, and it's actually the first time that I've ever been paid to work at all with open source communities, which has been both interesting and challenging, but it's still open. I'm permanently indebted to open source, so especially given the nature of this conference this weekend, if you haven't contributed to open source and you've just been a consumer, I heavily encourage you to get out and get into the communities of the technology that you're using. A couple of the places that I've been involved most recently for the last few years have not only been facilitating the Golang community through various RPM-based distributions, the AppC spec. I've been a maintainer on Docker and involved in Docker since the end of 2013. Just recently got moved to the an alumni maintainer on Docker because all of my efforts have been spent with the Open Containers Initiative upstream. Not only the runtime spec, now the image spec, but also the technical oversight board of open containers. So it's surprisingly pervasive because even if you're not familiar with some of these brands, obviously the Kubernetes logo is pretty straightforward, but Project Atomic is an initiative that is very Red Hat centric, but is now spinning into Debian and other distributions for container operating systems and being able to scale up containers and OpenShift origin, open source projects that you can go to GitHub right now and put your hands on that are working to use these same common standards. They've used the de facto standards and they're working constantly to support common standards. So why containers? And I love this because every time I mull on what's the proper English, and I'm sure some people in the audience could help me with English language better than I can. Yeah. I'm from Alabama in the United States, and I often joke that English is a second language. That why containers is sometimes like, why would you choose to use containers? And sometimes it's like, why, oh God, why containers? And because you have people starting off and they're like, well, containers are single application, and there's so many use cases where you want to keep a container as a single application, but there's also plenty of reasons that you'd want containers to be a full init system, and if you've used systemd inspawn, it handles the whole boot process. You have systemd inside of systemd, and there's a lot of use cases that you would want to just populate the unit files and boot it up and know that that sub-container is doing everything it needs to do. But containers are not VMs. They are their own, they're sharing the kernel, but their own root file system. But nowadays, containers might be a VM because we have unikernels and you have other thin hypervisors. You have containers that are mildly might be systems, you might have single application, and now you have collections of applications that make up a pod, like it's a service, and it just keeps on going. You have services that now span not just a pod on a local host, but you have services that span multiple nodes, and you have to be able to label these across infrastructures. Now we're getting into the new territory, well, I say new territory, but non-root containers. So we've tried to limit it and secure them and back it all the way down to what's the minimal set of security. And now we have non-root containers where you're still able to unshare the user namespace. Most of the other namespaces, C groups are kind of a pain in the ass still. But we're able to do desktop applications. Most people would want C groups in a desktop application. We'll get there. And of course, cats. I mean, my God, everything's got to have a cat on it for some reason. And a cat in bubble wrap, I'm sure it's completely safe. But what does container mean to you? Anybody want to wager, shout out, what does container mean to you? Anybody? Anybody? What does it mean for your infrastructure? What kind of assurances does it provide you? Sure.
Easier way to run my application with all dependencies contained in one thing, which is email.
Yeah, so easy bundling of packaging, and this is probably the primary use case. When it gets down to the actual execution, just like you just saw, there's a number of ways that it could actually run, single or grouped or system, but most people see it solves the use case of packaging and delivering my application. I know that the dependencies for my application I bundled at one point in time. And people see that and they're like, this is amazing. It's like rainbows and containers, and I put it all together and I'm pushing it out the door, and it's going to solve those use cases. And often by the time it gets to production, God knows what's in those containers. I mean, really. And you really hope they stack together. But a lot of this now people are realizing we're seeing lots of iteration. We're seeing lots of churn on this. And sometimes that churn is out of your control, and you realize not only now you're learning new things, you're encompassing new ways of deploying your code, you're going to have your own churn, and it will often mean new ways of doing the same things you did before. But as a means of what are the standards, the standards are really, how are we doing this? How is it, whether it's de facto or a specification that comes out of some governing body that most people really don't care about as long as it works. It becomes a thing that you can say, I did this and it works, and I did this enough times and I read about somebody else that did it and it works. These are the means by which you're going to compare the technology you're going to choose to use. So in containers, what do we have to standardize? First and foremost, by and large, it's packaging. Does the packaging work? How are we distributing it? How can I make software available to other people? How do I know that I'm checking all the boxes and the legal compliances? I'm not shipping out GPL code without the source code or a link to any of the information about that. I'm making sure all these things are done properly, dependencies and otherwise, but my mind tends to go to the worst possible scenarios of that runtime. So now you've actually got a package that needs to run somewhere in a fairly consistent manner, because we've been doing packaging for a long time, but the packaging plus runtime is the next big layer that you want to make sure it runs the same way every time. And now you have networking, and you want to make sure that you have multiple of these instances and they're building up and going further, and now you go even further and you have local infrastructure and you have cloud infrastructure or multiple cloud infrastructures, and you want to make sure that your churn is over your software, not the changing landscape around you. So, like I said, the past, present, and future of this is packages. Who in here likes tar archives? Show hands. Oh, that's good. Who in here uses tar archives? There you go. So 3 hands to 90% of the room. So tar archives have been around for a long time. Tape archives, they're serial stream. There's still good reasons for the way that it's packed and still very inefficient reasons for the way it's packed. And then we came along and people said, we can do this so much better, because SLS, Linux, and Slackware and all this stuff that would still tar archives. And Debian and RPM came along and had their battles and battled it out over whether to do it a Deb or an RPM. And there's benefits and drawbacks to both of them. There's still projects that will solve it in zip archives, and then more people came back around to tar archives, and then, I mean, it just goes on and on. You have the Perl pods and Ruby gems and Python eggs and more tar archives, and you have modules of NPM modules and whatever else, jar files, DMG, MSI, and you still have tar archives. And it's been baffling just to see how many problems we're solving, and we're stuck on this one thing of tar archives. But runtime. That was good. It was fine. It's completely fine. You have binaries. ELF made a pretty good impact for having mildly relocatable portable binaries, portable in the fact that you could recompile it everywhere and it should still work there. But the runtime was still very much like hands-on, like you had to be involved in the process, and having this kind of reproducibility meant that you knew that the binaries that you compiled were for the system you're running it on, and you have shell scripts, and that's, you know, get blended, and especially in the Linux world, to sysv init, piles of shell scripts. War files actually made a pretty decent progression so that you could have an object that you hand to somebody, and it's got pretty much everything it needs, the configurations that need to be exposed, where it needs to listen on. And I'm sure there's so many more of these, but you get to so many operation shops, and whether they're using config management or their own home-baked system to make sure that runtimes happen in the same place in a lot of different locations, it ultimately ends up looking like shell scripts. Is that true or not true? Everybody? Yeah, I see some nodding. Everybody knows those pains. They don't want to talk about it. So networking. Traditionally, networking is very, very hardware-centric. It was specific interfaces to the hardware, depending on whatever manufacturer it was, but to configure these things, you either had to have hands-on access or eventually some kind of customized shell that you accessed over a port. Still very, very custom, and finally we're working our way along to the world of SDN, where it's a little bit more automated. And cloud, I can't hardly say for past. I mean, it's just painful of APIs at this point, but still very much HTTP based. So to present, where are we? You have the Cloud Native Compute Foundation, CNCF. How many folks have heard about that? I've already heard about it a couple of times today. Cool. So Kubernetes, most people are asking, what does CNCF mean? And it's a governing body working towards making sure that when you are pushing your applications out to scale all over the internet, the cloud, that you have at least a consistent way of knowing what to expect. It's not just completely going down a rat hole of some particular industry's lock-in. And the Kubernetes project has been offered as a seed technology for this, which is strongly two different things, because Kubernetes as a project is incredibly strict about their API. They're API driven, and they're strict about this. And secondly, as a community, they are very allowing of you coming in and working on an extension to Kubernetes that will support your use case as long as you're not breaking other people's use case. And it's got a very strong test-based, it's got a very strong review process of, like, if you're needing to make an API change or addition, that this is something that would make sense and could be supportable on a long-term basis. As a community, it makes a lot of sense for having an API based on how to scale out your application, how to spin up new instances, whether it's on your own infrastructure or in the cloud. So then presently on networking, as far as standards go, in the container realm, the CNI, the Container Networking Interface, it was initially launched as a part of Rocket. So it dates back to December 2014 because it was rolled into the way that Rocket did networking when Rocket Proof of Concept came out with around the time of AppC. But CNI now has its own place that it lives. It's by and large completely separate from Rocket and AppC. Rocket still references how it uses it, but now Kubernetes is merging in support for CNI. So as long as you have a plugin that's written to this specification, it'll work in future versions of Kubernetes. But as a plugin infrastructure and specification, for folks who in this room might be writing a network plugin. Companies like Weaveworks and otherwise are the ones that would come to mind, but anybody in here would be writing possibly network-like plugins. So the model is simple in that it allows the network plugin itself to maintain its own state. You're not at the discretion of the daemon or whatever that's using it. You could actually maintain your own state as a network plugin model. Not necessarily requiring of an outside daemon for you to run it, but you could do that if you need a daemon to manage that state, but it is independent of the framework that will be using your plugin. So in that way, it has a lot of simplicity. This spec is implemented by Rocket, now Kubernetes, Karma, Cloud Foundry, and it's generic enough that it can be used with runc, the open containers runc command line, and as well as many, many more tools. There's also the container network model, CNM, which came out a little bit later in the year after CNI was out and being implemented. So libnetwork, how many folks have interacted, put hands on Docker libnetwork? Okay, so a handful of folks. It's by and large harder to integrate with, and I'll make these slides available later. The hyperlink there goes out to Tim Hawkins from Google and the Kubernetes team. Tim Hawkins' email of a blog of why, as the Kubernetes project, they completely are choosing to not work at all with the libnetwork framework model because it takes away a lot of the control that you would need as a network plugin implementer. And right now it's this network model, it's got a document, a README up there, is by and large only used by Docker and plugins that have written to work with Docker's networking model. So present runtime, we've had LXC for a long time. It's still very, for quite a long time, but it's still very LXC specific code. Thankfully, it's all very namespace, so you could put your own logic in there, but it's very LXC specific. How many folks used LXC back in the day or still do? Nice, good. So LXC is still such a winning story, and everything that Canonical's done with LXD as well, but it's been even interesting in the container ecosystem the last couple of years to see folks like Flynn that started off with some particular technology have had an immense amount of stability by switching over to something like LXC. So kind of a old school, long running, but still plenty of a de facto standard. So Docker, everybody's, I'm sure, heard of or put hands on Docker 2013, so they're running on 3 years now. But all the Docker integrations are very specific to the Docker configurations, any kind of integration APIs, otherwise, whether you're talking to the daemon or the registry or just the command line interface. So the application container spec, you've heard this mentioned a couple of times today. December 2014, and when the AppC spec was announced, it got quite the reverberations that I'm sure the CoreOS folks are expecting, but the most interesting part about it was that it walked down a laundry list of most folks that were actively contributing in the container scene up until that point. Were asking for it to be standardized, asking for it to be implemented, the content addressability, the ability to sign images, the ability to have discoverable images on the internet that aren't in a centralized registry. There was a number of items, but it walked down the list and addressed all of those in a very straightforward manner. And as far as the runtime specific is concerned, the execution environment, there's in the AppC spec repo, there's a spec directory, and there's an ACE.markdown file that walks through exactly what you can expect from the container startup, creating the sandbox, execution, how it's all layered in. It's itemized straight through, and you can implement to that spec and have your own container runtime tool that is not dependent on any other tool. So there are a number of implementations of this. Obviously, Rocket is the flagship implementation, and it is by and large a spec first implementation. The Open Container Runtime spec is how many folks have glanced at, obviously you heard, maybe not obvious, but you might have heard of the Open Container spec. How many folks have looked at the runtime spec? Minimal. Nice. Oh, that always makes you feel warm and fuzzy when you toil away at something. So the Open Container Runtime spec was offered up something like 6 months after the application container spec was made available, and it was a huge peace offering. There was a display in the stage, and Polvi and Solomon shook hands, and the container wars were over, and it was offered up as runC, the command line tool runC, which had been effectively a debug-only tool first. It was a way that you could connect to containers that were spawned by Docker in a very Docker-esque way. It was offered up as runC, and the spec as a specification of the configuration files, the runtime, all this kind of stuff, effectively has come out of what runC expected. So it was an implementation first, and so kind of a bottom-up specification in that regard. And at this point now, there are several implementations of the runtime spec. runC is the flagship one. It's on the Open Containers GitHub project. And most of the implementations of this spec are looking to be compatible with runC, so that when Docker calling containerd calling runC happens, that they can drop in, replace that binary of runC. So they could do, like, there's a runV for virtualization. There's a Solaris zones integration that's coming out. And so most implementations of the spec are looking to basically have a tighter coupling to what Docker is expecting. And its 1.0 is currently roadmapped for just next month. So as a packaging standard, and this packaging is really where most of my time and attention is focused on. You've had the Docker format, which is by and large, it's a custom format, and it's been what has grown with the Docker tooling as it's evolved over the last 3 years. It now has, since the AppC spec came out and addressed a way to sign in a very reliable way, sign container images, Docker now has signing that is implemented using the Tough spec, the update framework. If you're familiar with how Python and a few other projects do signing and rotation of keys of signing. Docker now has Notary. It does require the Docker Notary integration to do signing. So if you have an existing PKI framework, or if you have an existing like GPG process, it requires using the Docker Notary process, and not quite pluggable in that way. And all the naming of images is very specific to Docker and Docker registries, the transport. Application container spec, we've already touched on a few pieces of this, but this is talking about the ACI image format. So ACIs are much more detached from any given registry. It is a tarball that includes the container configurations as well as the root file system, or references to other remote file systems if you need them. So when you are pulling down an ACI, it might have dependencies in it that are not contained in that container image itself. So it allows for more of a federated layout. You could pull from one company's website that references a specific version of a base layer that is hosted by somebody else entirely without having to have a centralized registry. But it addresses that kind of fully qualified naming. You have TLS negotiation to the company or to the website that you pulled the image from, a way to discover it. You have content addressability, so you know exactly which image you were expecting and you got, so on. Has anybody implemented or otherwise done an integration to the ACI spec itself in here? Yes, okay. You should go out and put your hands on it. It's surprisingly elegant, well-written spec. And then most recently, like seriously, very, very recently, is the Open Container Image spec. It was spun off by and large because a lot of the companies that got involved with the Open Container spec as it was prior, many of the companies that got involved expected the spec to encompass distributable packaging image, and it was clear that many people involved were interested in only the runtime, not a distributable image. And so after some months of arriving to this conclusion, it was spun off as a separate project. So there's now not just a spec, but a runtime spec and an image spec, so that we can address some of the items like content addressability, the ability to sign something, an object that you can sign in whatever your framework is, and now to start building on fully qualified name that's not specific to an API, and whatever discovery it is that you need to implement, so that you could actually piggyback aspects of the application container spec discovery and otherwise here. For reducing the amount of churn that people that are doing container tool integrations, it was pulled from the Docker, the image format was pulled from the Docker 110 container image, and the distributable content addressable manifest is pulled from the Docker v2 registry. And this is by and large because there are so many companies that either have their own registry implementation or infrastructure that is supporting the current Docker v2 registry. The GCR.io, Google's registry, Quay, Dockyard, Red Hat has an atomic registry that already support this format, and it is the full intention that the 1.0 of the image spec, Open Container Image spec, should be at that support level so that it won't be a breaking change just to get on board. It will be the tooling to get involved, will be reusing your current infrastructure without breaking changes. And once there becomes a consensus, that we can start moving forward on the other changes that would be like a V2 or whatever possible breaking changes later on. So why more standards? It's one of those age-old things, and welcome to the open source community, but everybody looks at things and find that there's a new way to solve the same problem in a better way. But by and large, the biggest reason that I can encourage anybody, and if anybody had history enough to be involved in Linux 10 years ago or more, the Debian versus RPM battle rift, and it's not even talking about a flame war, just fundamental disagreements and engineers going head to head on which way is better, and them having personal vested interest because they had their hands on the keyboard and they wrote some piece of Deb or they wrote some piece of RPM and they go head to head. The Debian versus RPM rift single-handedly set back the widespread adoption of Linux, I'm sure by 10 years or more. Companies that were ready to invest in this probably said, wow, that's too much volatility. We're going to wait until Linux simmers down. And here we are 10 to 15 years later, and we've kind of swallowed the pill of you have a lot of packaging formats. RPM and Debian are just some of them. but the pattern of the argument that's happening of like this way versus that way, and I've had my hands-on keyboard experience and I'm trying to block what you're doing and I'm trying to lock you into what I'm doing, that will single-handedly set back a lot of people's impression of containers over the coming years, and nobody needs that. Like Brandon says, the standards that we're working on are to ensure that your churn over the next 3 and 5 and 10 years is as minimal possible, and it's your own code, not due to the environment that your code is having to live in, the ecosystem. So I could touch on a few pieces of like what we see in the future. I think it's funny that content addressability is a huge thing, and Brandon has an announcement today of BitTorrent. It's exciting. But really the call to action is, as you are entertaining these container integrations, honestly, define your use cases first. It's very easy when you're hearing about some of the hot technology to say, oh, it solves this use case, and it solves that use case, and it solves this other one that I didn't even know I had. You really ought to be defining your requirements first, defining your use cases first, and sometimes even what it does and doesn't mean, because if you find yourself signing on for one particular use case, but it now makes other things more difficult, that kind of evaluation needs to happen early so that you're not locked into something later on. Get involved in the conversations. The open containers development is an open mailing list. Anybody can read. There's a free node channel. Unfortunately, it's the way it's assembling. Many people won't have tooling that they're going to start writing until it hits a V1. And I realize it's a very difficult landscape to get involved in something that is only really set to take off once it hits a 1.0. But it's still, if you have experience in some of these arenas, either as somebody who's implemented original tooling, packaging, networking, runtime, or somebody who will be implementing tooling to integrate with it, get involved. And make sure that where possible, given what you're going to learn, that your container integrations with tooling or infrastructure, as much as possible, can stay generic so that you're not putting yourself at risk for lock-in or otherwise, because there's so many good tools. It's got such a great future, but if you're locked into one particular way of doing it because of the way a tool does it, you're putting yourself at risk, and that's not necessary. Yeah, and then proof of concept tooling, because it's always welcome to kick around new technologies. So get out there and try it. That's pretty much it. Thanks for listening to a mild, very soft rant. But if you have any questions, open up the floor now for folks. We have like 4 minutes left, 3 minutes left. Seven? Oh yeah, right, sure. Including questions. So 7 minutes left. Yeah. Oh, okay, one in the back. There wasn't a mic to walk around. Yes, you can shout and I'll repeat.
Okay, cool. So given that like OCI image spec is building upon Docker, how can we expect Docker to have uptake and basically merge itself now in the situation without
So if I heard it all correctly, you given that the OCI, the Open Containers image spec is built or taking from the way Docker has done it, that you would assume Docker will adopt it? Yes. Will or won't? Will? Yeah. That is absolutely the question. And there is a part of the Open Containers umbrella, the foundation umbrella, that I have not been terribly involved in for certification and compliance. And it is going to continue defining what it means to be open container compliant. So just saying OCI compliant might eventually mean what piece of it, because up to this point, it's just the runtime for Docker. And the question has come up from a couple of different sources of like, how will this integrate? Will it mean what they're pushing to a registry is an open container image? that would be great. It might end up being just piece of like Docker save and load -- format equal OCI v1, so that you might have your build infrastructure that interfaces and other, however you've managed your own tooling, and then if somebody wants to pull that into a Docker workflow, that they can save and load it, and then you would be under the auspices of however they do signing and transport. But presently, I have not heard particular plans from Docker on how all they will be compliant with the image spec. It's primarily the runtime spec. Good question. Anybody else? Solid. Well, good. If you have any questions or if you want to go over any piece of it, I'll be around for today and tomorrow. So thank you.